have three others doing the same talk by Docker. And after this, we have another talk by Sujay. And he's going to share his experience about moving a bunch of people from VMware to containers. So yeah, let's get started.
Cool. Awesome. Good evening, guys. So myself, I'm Gracel, and I'm with ThoughtWorks. So this was a change that happened in the last minute. So we decided myself, Abhi, and Santosh would take up. We'll give a brief overview about Docker, Docker containers, and Kubernetes. So the idea of these two talks is that both talks would be complementary. So whatever we do in the first talk will be used, or you'd see the effect of it in the second talk as well. So that's the idea. Okay, so let's get started with Docker containers. So probably if you're a programmer or a techie, it's the chances are that you have already heard of the term Docker. How many of you have heard of Docker or have used Docker? Pretty much full house. Cool. So we'll just start with a basic introduction. So what is Docker? So what does it do? So in layman terms, to put it in layman terms, Docker is essentially a tool which helps you run your applications in isolated environments called containers. All right. So what about these containers? So when you talk about running applications in isolated environments, does it ring a bell? Has there been a traditional way of running your application isolated? So virtual machines, yeah. Okay, so we have virtual machines and we have containers. And there's this very common misconception that containers are virtual machines. But that is not true. There is a lot of difference between containers and virtual machines. Okay, first of all, why would you actually need, what's the need to run your applications in an isolated manner? What would be the need? Can anyone point out? Why would you want to run it in? Security, okay. One. Okay. Sorry? Availability, good, yeah. So yeah, I'll just take an example. Let's assume you have two services, service 1 and service 2, and both your services run inside a single machine, a single server. Okay, and assume assume both your services are built on a particular framework. Let's say Spring or something, and there's been an update in Spring. So when you update both your services, there is a need to update service 1, because let's assume it has something to do with the monetization of the company. So you end up updating both your services. Service 1 works fine, but then once you deployed, you realize that service 2 is not compatible with the change in the framework. So what happens is everything breaks down. Yeah. So in this case, you might want to move service 2 to another server, fix it and move to another server, and you run both on different servers. The problem here is both the servers are absolutely underutilized. Yeah. You might be just using 10% of your first server, which is running service 1, and just 10% of your second server. The remaining 90% of both servers go into waste. So in order to solve that, the concepts of VMs came in, wherein you have a single physical host machine, on top of which you spin up two virtual machines, deploy your applications, both services and separate virtual machines, and run. In which case, even though service 2 breaks, service 1 is still available. Yeah, so that's the idea about virtual machines. So how does this help? I mean, like containers and virtual machines, if you see, both have similar goals. So the goal is to isolate your applications and run. Not just that, so they save a lot of physical hardware as well. The exact same case which I was mentioning here. You could use one server instead of two, and you could end up saving a lot of energy and a lot of resources as well. Yeah. Okay. Cool. Before we get into the crux of the topic, can someone tell me in brief what is cloud? Right. Yeah. So it's basically on-demand provisioning of resources Yeah, and I guess most of you are aware of different offerings of cloud. Yeah, can you give an example for each? Infrastructure as a service, any examples? AWS, cool. Platform as a service, Heroku, yeah. Software as a service, yeah. A lot of, yeah. So what's the latest offering in cloud services? That will be containers as a service. So containers as a service is the latest offering from cloud services. So Docker is one such tool. Cool. So before we, so we've seen, right, containers and virtual machines have very similar ideologies or goals, but where do they actually differ? The point where they differ is their architectures. Okay. So before we go into the architecture, so most of you have deployed on VMs, have worked with VMs, right? Yeah. So you mostly go through this process to set up your environment. You provision your VMs with your guest operating systems. You create users, define who has access to the VMs. You install all software that's required to run your applications on the VM, and then you deploy the application, right? So simple. So VMs, so virtual machines. So what are virtual machines? So virtual machines are basically they are the machines which are run on top of a physical machine. A physical machine meaning a real computer, wherein it gives the illusion that the idea behind virtual machine is it basically virtualizes the hardware setup. Yeah. So when you have a virtual machine, you have the host machine. You can build multiple. You can spin up multiple virtual machines, and each virtual machine can have its own memory, CPU, disk space, everything allocated. Yeah, sure. Yeah. So this is how a structure of an application running on a virtual machine would look like. Sorry, excuse us for a second. Yeah. Cool. Okay. So in this example, we have 3 applications which run on 3 virtual machines. So 2 of those machines run a Linux guest OS. The other one runs Windows, and your host operating system could be anything. Let's assume it's Windows for now. Okay. So you spin up your virtual machines, your application's up and running. So how does your machine communicate with the host operating system, or how does it use the resource or the infrastructure that is available in your host operating system? Okay, so that is where something called hypervisor comes in. Okay, so let's unpack the jargon. So what is a hypervisor? A hypervisor is basically a software or a firmware which takes instructions from your virtual machine, converts it to a form which your host operating system would understand and interact with your hardware here. Yeah. The problem is, since these guest OSs are different, you have multiple guest OSs, each one would have its own kernel, correct? And your host operating system has its own kernel. So whatever that comes from that kernel has to be converted to something which is readable, which is understandable for this kernel. Yeah. So that is an overhead. So that is where that is probably one of the drawbacks of virtual machines, because it takes a performance hit because of this translation layer which lies in between. Yeah. Cool. So that's pretty much the challenges with a virtual machine. First things first is resource utilization. So obviously your guest OSs, you have ISO images of which you would spin up, right? So what is the normal size of the image in a virtual machine? Easily, right? So it takes a lot of space, and it is definitely going to consume a lot of CPU and RAM. And as I said, the translation layer with multiple OSs and the hypervisor, it's going to take a hit on performance. Yeah. And also there is cost overhead, because you might have to buy software licenses for your guest OSs which run on your virtual machines. And there's always a cost with maintenance and upgrades. Yeah. Cool. So how does container model help overcome this? Yeah. So similar scenario, we have 3 applications running on 3 different containers now. Okay. And there's a container engine. So we are discussing about Docker containers. We have a Docker engine. You have the host operating system and this. Yeah. The thing with containers and thing with Docker is your host operating system is always Linux. Yeah. So if you're using a Windows system or a Mac OS and running using Docker, so you would download something called Docker for Windows and Docker for Mac, right? Which will internally, it's not seen, internally spin up a Linux virtual machine and then run your containers on it. Okay? So what we have here is, we'll have one virtual machine and multiple containers running inside the same virtual machine. Unlike the previous scenario, where we had multiple virtual machines running different OSs. Yeah. So the advantage with this is everything shares the same kernel. So there's no need for any sort of translation, because your host operating system is always Linux and your containers are always flavors of Linux. Okay. So that translation overhead could be avoided with containers. Yeah. So that's the biggest, positives of using containers. Yeah.
Even if we had Windows to Windows VM talk to Windows host OS, do we need the conversion between the VM and the host OS?
Would not be needed much, right? Yeah.
And there's a similar case, right?
Yeah.
We could even probably have Windows VMs in the
Yes, it could be all Windows. That is an ideal scenario, but there could be cases where you build and develop on multiple environments. Yeah, so in that case, it makes sense. All right. So with that introduction to containers, let's move into Docker. A little bit about the Docker architecture. So you have a Docker client with which you would communicate. When you install Docker, all this is packaged and given to you. So you have a daemon Docker, which will hold, which sort of like performs whatever command you give. It sort of executes these commands. So it's like a client server architecture where in your client you give a Docker build or a Docker run. Those commands are taken by the daemon and then executed. So this is where your images are placed. When you build something, you create an image, and you run an image. You get a container. So images are basically, they're like class files, okay, and containers are like instances of your class. Yeah, right. And there's also a registry wherein every image that you build, you could push to the registry. Cool. And also so this is the local cache, and this is the Docker registry, the one you see online when you want to pull in any image from online. You just go to the Docker registry and you do a Docker pull, you get it. But most of the times, if that image is already present, if you already used the image before and you do a Docker pull of an image, it first checks in your local cache, it sees if that image is present, picks it up. Otherwise, it goes to the registry and picks it up. Cool? Right. So yeah, so you know what an image is. You basically bundle all your code into one single unit. Yeah, so that basically is what an image is. So how do you build images? Okay, so there's a small demo which would follow this, but I'll just give an overview of it. So you create Docker files. So whenever you want to build an image, you create a Docker file, and when you give the build command, your Docker file gets executed step by step. Yeah, and that will build an image. We'll see how it happens. Yeah. And these images you could run, that'll spin up your containers. Yeah, and again, yeah, so that's pretty much what happens here. And also you could push your images to your Docker hub. So that is something you could do. And again, someone else can pull your image which you had pushed to Docker hub and use it, spin up the containers. So Dockerfile is a document which contains all the commands required to build an image. Versioning Docker images. So this is important, right? Because when you're building an application, you're always going to be iterating on it. So you're going to be releasing version after version. So every time you release a version, it's good that you tag your image with the latest one, so that someone else, when they pick it up, they'll pick up the latest version and not an outdated one, right? So we'll see how we can tag an image as well. Yeah, so this is like basically it's more like a convention. So you give a namespace followed by the actual image name. Namespace could be anything. Like let's say if within ThoughtWorks there are multiple teams, and everyone uses the same or a customized Linux image. So I could have the team name / the image name and the version. So it's just a convention. It's not a compulsion. Yeah. Okay, so we'd have a demo now. Cool. So this is just a simple Express Node Express application. I'm just listening on port 4000, and when I get a request, I print hello world Docker. Yeah, this is what the application does. That's all it does. So prerequisites is I have to have, okay, what if someone tries to run the same program but does not have Node or npm or Express installed in their system? What would happen? Yeah, it's going to throw out an error, right? Saying that Node is not installed or anything. Yeah. Okay, let's see how Docker would overcome that problem. Like how helps us resolve that problem. Cool. Let's just check this if it works fine. Okay. So I was listening. $4,000, right? Cool. Getting it? So let's see how this works in Docker. Cool. So the first thing would be to build the entire app, right? So before that, let's look at the Docker file. Cool. So this is the file which is going to help me to build my image. Okay. So from Node. Okay. So from Node basically means it's the equivalent of Docker pull node. Yeah. If you do a Docker pull node, it'll pick from the registry and it'll save that image in your local cache. Okay. So from Node is your base image. So I could have used an Alpine version of Linux or anything. It's just that I wanted Node to be already installed in the image that I wanted to use. So that'll be my base image. Okay. And I'm copying everything in the current folder. So here you see everything here to a folder called app, right? And the reason why I said this is it will run this command from this directory. The next command, npm install -- quiet. Okay. So you have your package.json file here, and when you do an npm install, it's going to install everything that's been specified in your package.json, right? And this is just like a command for you to start. Like this is what we give when we manually try to start the application, right? So it's the exact same thing, and you would expose this port as well. So your container signifies your container is running on this port, on port 4000. Cool. Yeah, it's a public this thing, right?
Common Docker repository is a public one. So if you want to work, like you can maintain a private for your organization.
How do we choose images between multiple?
So that is based on your requirement. Suppose you want to run your application on Linux, so you can choose the Linux images.
Is it basically operating system or just the runtime environment?
So it's a operating system. Dependencies package.
You can just take it as if you see the image just have all the dependency.
Yeah.
You should be very clear. It's not the operating system. It's not going to run anything. It is just your
Basically,
application is going to run. Any library dependency that it is going to call has to be there in the image.
Yes,
Yeah.
that means it's a runtime environment. Only
Yeah.
for that.
Exactly. Whatever it is going to call, only that is enough. But basically, what you get from Docker Hub might have more.
Yeah.
Because they make it general and have it there. When you want to determine for your production cases, you need to
Using this. Okay.
So you'd essentially have your libraries and binaries required to run your application. That's it.
But it doesn't have the OS.
No, actually you have the OS. It's a customized version of the OS. It's not the original, the actual OS.
It's yeah, bare minimum. If you have a look at the size of the image, it'll be very less. If you pull an Alpine image, it'll probably be 5 MB or something. It's the bare minimum required to run your application. So that yeah.
Okay. When I think it does have the OS, I'm able to compare it with the same as. Oh yeah.
Cool, right? Okay, so let me try to see how Docker builds an image out of a Docker file. Build dot. I want to tag my image. I want to name it, say, GeekNight Demo, and give it a version. Okay. So it's doing a pull from the registry. So it's not available in my local cache. Yeah. So you would see the difference. Like if I run the same command once these steps are complete, you would see how fast you would have a new an image, because it takes from the local cache. Right now there's nothing in my local cache, so it's pulling from the registry. Let's take a look. Cool, right? Our image is now built. You want to see what was built? You do a Docker images, and you could see your image here. So that's the name you gave, right? GeekNight Demo, the tag that you gave, and comes with the image ID. It was created 7 seconds ago. And yeah, this is the size of the image. So this one is a bigger image. So this is 676 MB because I pulled a bigger image. So that's the reason it's why it's bigger. So now this image does not just have my node base image. It has everything here. Where is it? How do I exit the presentation mode? Cool, right? Let's go to another. It has all of these. Okay. So I would ideally push this image to the registry, and probably one of my teammates who wants to develop, he could just pull the image, and he does not have to install npm, or he does not have to install node, he does not have to install express. All he has to do is pull this image and run it, and you'll be able to see what we just saw on the browser, right? So there's often this problem, right? It works in my system and doesn't work in his system. So there's hardly any chance for that to happen with Docker images. I'll just build the image. So this is ideally what someone who pulls the image would do. I would do a Docker run. Okay, there's something else here as well. So you will have to do a port mapping. I'll tell you why you would have to do. So your Docker container is exposed on port 4000, right? So if you do a localhost 4000, now it will error out. So you'd have to map your port here. So when you're calling from localhost, you have to map. So it's basically this is basically a port mapping wherein you say, if I hit localhost :8000, redirect me to port 4000, which is your containers port. So that is what would happen here. Yeah. Sorry. Yeah, it can be. Yeah, yeah. This port mapping can be part of the Docker file as well. Yeah. Okay. Just take the image ID. Gosh. -t. Sorry. Cool. So you see this app here when the container spins up. So that is exactly what you have mentioned here, right? So you're basically copying. So if you see this step, you're basically copying everything to this folder, right? To the app folder. If I do ls here, okay. IT, sorry, missed it. So you would have all your application files inside this folder, right? Here I could just do a node index.js. Your server is listening on 4000. It won't work because you're mapped, right? So what have you mapped it with? It'll be embarrassing if it doesn't work now. Cool, it works. Yeah. Cool. Cool. That is pretty much what I had. Yeah, that's pretty much what I had. Yeah, so I think we'll move on now to Kubernetes. So the idea is to cover the basics of Kubernetes, and you would also see how containers are used in Kubernetes. Yeah.
Okay. Hello all. So this is Abhinaya. I've been in ThoughtWorks the last 3 years. So we'll start with Kubernetes. So how many of you have already worked in Kubernetes, just to get the idea? Okay. Okay. So okay. I thought I'll start with asking the question. If someone wants to take a dig at what is Kubernetes, or what do you think it does? Yeah. So Kubernetes is a open source platform again for managing containerized workloads. So Gracel did a intro on the Docker, right? So once you've deployed all your applications using containers, so in an ideal case, say in a QA environment, maybe you can just live with a single host where you deploy all your containers, you're just done with it. But that's not the real case, right? In production, you would want to span across multiple hosts, you want to maintain them. So those cases, container orchestration needs to be done. And there are a lot of tools, there are a lot of people who've done this. So like we have Docker Swarm, we have Mesos, and a lot of these. But today we'll be speaking about Kubernetes. And like first of all, why do you think we need container orchestration? We know it's a lot of work, but can someone just Tell me, why does it need a separate orchestration? Yeah, scalability is one. Sorry. Yeah, you're talking about the deployment, right? Yeah. Yes. So each of this is a use case on its own, and there are a lot of other things as well, right? So there are some. You might have a lot of, now you're connecting to multiple hosts. So connecting one container to the other host itself comes automatically when you have a orchestration manager, and let it be attaching your storage to your container. Though it's available in Docker, that's much more premature when you compare to what our orchestration manager will give it to you. And also, uh, the cases where, say, you're running multiple instances of the same application to load balance. So if you have an orchestration manager, it gives you an abstraction where you can just, all your application need to access a single name, and internally the orchestrator takes the hard task of mapping it to the right container. So these are some of the things. We'll take each thing in details later. But just, is it convincing to say that we need a orchestration manager? So yeah, so a bit of history about Kubernetes. So Kubernetes is derived from a Greek word which means the helmsman. So like we have a pilot to maintain a ship, like a mariner or a captain who maintains a ship. This is for all the containers. And sometimes ship is also known as a container, so yeah, that's the idea. And originally it was Google's project. So they had, so till 2015, it was almost like Google's secret in managing all the containerized workloads. See, all the applications that we have, that we use every day, say Gmail or YouTube or anything, even the Google Drive, right? All of these are again containers running in the Google system. And till 2015, it was almost like a secret that Borg was used to maintain all of this. In 2015, they decided that let's start something, and donated to the Cloud Native Computing Foundation, which is the organization who currently takes care of the maintenance of this. And Kubernetes is also known as like K8, just because there are 8 characters between K and S. Okay, before we start into it, do you have any doubts, or do you want to ask more, be more familiar with Kubernetes? Okay. Yeah. So since it's a short talk, I'm not sure how much of things that we can cover as part of Kubernetes here. But just to start with the abstractions, this is one of the, what do you call, the selling point of Kubernetes. So there are a lot of times we have tools like Ansibles, right? We've started with a phase where we have a single shell script which will take care of deployment. And then you have things like Ansible, Chef, and Puppet. But all of these, Ansible, for example, is an on-demand tool. You ask it, and you ask it to do some configuration changes, and then it's done. Then you have a separate tool for managing, monitoring, and logging. And then there's a separate tool if you want to auto-scale. So all of this is done by 2 or 3 different systems, right? So Kubernetes is almost like an ecosystem, a live system which is always there, which takes care of all of this. And yeah, so one of the main things about this is the reconciliation loop. So Kubernetes runs this loop always. This is like one of the daemon that is running within Kubernetes, which always checks what is your desired change. So it might be much more clear if you go into how do we define the specifications to Kubernetes, but at a higher level, consider it to be something where, say you're specifying certain requirements for your applications. Yeah, properties in a pod file, but we'll come to it a little later. But a very high level, say you're specifying some things to be must-have for your application. Kubernetes, you can be rest assured that Kubernetes will take care of it, because it maintains a continuous loop to check if the desired condition is always met. So let it be the number of nodes, or let it be, say for example, your node is down. In that case, it takes the task of moving the pods, but in a way moves the application to the other nodes, as well as say if a container itself is down for some reason, and then you have to indicate it, but it will be able to retrigger or restart the container. So some instances it might get restarted after a period of time, right? Those cases would be automatically handled by Kubernetes. So all of these is possible because it continuously keeps checking whether something has changed and whether the desired stage is still met or not. Yeah. The high-level architecture, so Kubernetes is more like a client-server organization. So you have the master, and then you have the node. You can have multiple masters. In that case, one master will be elected as the leader, and you can have multiple nodes as well. So creating the Kubernetes cluster is a tedious task, but there are like one-step process these days to create it. We have the Google Cloud Engine where you can just create it automatically. I mean, like you need to specify how many nodes you want and other parameters, and with that you can just create the Kubernetes cluster. It's more like Kubernetes as a service. So yeah, so coming to the architecture, like any other client-server system, right? So the server takes the task of getting all the requests, and it delegates all the work to the nodes, whichever node is available or more appropriate to do the task. And the worker nodes, as the name suggests, they do the hard task of doing the workload. So it's as simple as that. Okay, coming to the master. Okay, so in the master, we have the API server. So if you see, none of these communicate in between them. Everything goes via API server. So say if you are hitting a command to Kubernetes, if you're trying to communicate to the Kubernetes cluster, that goes via API server, as well as the communication between the client and the server inside Kubernetes ecosystem itself happens via the API server. So yeah, that's about API server. And then you have the scheduler. So as the name implies, it does the job of scheduling which work has to be done in which node. And so it does the task of that. And how does it do it? So if you see in Kubernetes, everything is stateless except one component, which is the etcd. So etcd is the key value store that we have. So that's the only stateful component in Kubernetes, which maintains all the information that you need that is associated with the Kubernetes cluster. It's almost like if you think of erasing a hard disk, then this is what. If you erase etcd, it's almost like your cluster is gone. It's like the memory of Kubernetes. And then you have the controller manager. So if you see controller manager, like I told, right, we spoke about the reconciliation loop, which always keeps running. So there are a lot of controllers that are there in Kubernetes, which are more like daemon jobs, which keep running always, which will ensure that something is right. So one can be, say you've specified that I need 3 replica sets for your application. In that case, there is a controller which specifically takes care of to ensure that you have 3 instances of your application up and running. And there might be one more controller which takes care of about whether your node itself is up and running, and there's no problem with that. So all of these controllers are managed by a controller manager. So this is the one which takes care of all of that. And how does it do that? So it gets the information from the etcd about the current state, about the desired state of the node, and then it does the mapping. So all the data part of the Kubernetes is stored in the etcd. The rest of the people consume that using the API server and do the job. Okay. Okay. kubectl. So kubectl is the command line that we use to interact with the Kubernetes cluster. So, but we'll be having a demo where we'll be hitting the kubectl commands. So in a very higher level, in kubectl, the command would be something like, it's more like the verb that you do, the create, the delete, the applying of configurations and all of that. And then the type is, there are a lot of Kubernetes objects. We'll be discussing about that. So, I mean, you can imagine any applications to be done and deployed using Kubernetes. It might be an application which maintains data, or it might be an application which keeps logging to a like some log manager, or it can be like something where it's more like a cron job where it's scheduled and it does a periodic job. So it can be anything. I mean, or maybe just a web service which has to be exposed as a service. So any type of application that you consider, each of them is supported by Kubernetes by using the concept called Kubernetes objects. We'll be talking in detail about each of these Kubernetes objects. So the type here actually maps to that Kubernetes object. So it might be a secret that you're creating, or it might be the actual instance that you're creating. So all of that would be coming under the type part. Okay, so coming to pods. So when like Grace was speaking about Docker, we always speak Docker with containers, right? So container is the single or the most atomic unit of execution in Docker environment. In Kubernetes, pod is the single most atomic most unit of execution. So whenever you want to specify an operation, you are actually talking to a pod. So like at the end of the day, if you see Kubernetes, you specify a Docker file to be executed, right? At the end of the day, Kubernetes does some sort of an abstraction over that. And that sort of abstraction is given by creating a pod. So you can ask me, why not I run a container itself? Why do I need to create an abstraction over that called a pod? So Kubernetes, all the features that we're talking about, right? The reconciliation loop, how does it maintain the health checks? All of that is like a package. And that it achieves by creating a layer of abstraction over containers. Yeah, and in a pod, you can have more than one containers, but I'm not sure how many cases that you'll run into where you want to run more than one containers in a pod. And also, if you want to scale your application, how would you do it in this ecosystem? Sorry? No, actually you increase the number of pods and not the containers inside it. So you put 2 containers in a pod not for scalability reasons. You put two containers in a pod to achieve a specific case. Say for example, you have a pod and you have one container which runs the application, and the other container, say for example, it needs to periodic backup of the data it has. In that case, and if it's say it's an external volume, so then it makes sense. Even that, you can have that mount that volume in a separate pod and do it. Or maybe there's an application which logs information. In that case, say it logs only to the current directory or in that ecosystem. In that case, since 2 containers in a pod share almost the same thing, they share the same data volume itself. So the /bin directory would be the same for this as well as that. So in that case, it makes sense to that. Otherwise, for scalability reasons, for any other reasons, it's not better, it is the way to create more number of pods than to create more containers in a pod. Santosh, any questions? No, it's a single, the etcds alone, it's distributed. Since it's a data store, it's a distributed data store. Rest of the application is still in a master, single machine. Sorry? 3 services inside that. The scheduler and all of that, right? So, I mean, at the end of the day, it depends on, say, if you're creating a pod specification for your application, it depends on what you want. Say, if you want 3 replica sets, there are going to be 3 instances of your application running, which means there are going to be 3 pods that are running. Code mapping. Yeah, it takes care of the, I mean, it's more like the same way that you specify ports in Docker. So, like you specify, probably if you run through the files, it will be more.
Hi, I'm Santosh. So I'm a developer here. So yeah, like, in Kubernetes, like everything will be treated as objects. So like we saw that like pods. So it's an object in Kubernetes. So objects is a like in Kubernetes the objects is a persistent entity in persistent entity. Like what is persistent entity? So like we are going to store the configuration everything on the etcd, right? So the configuration like the objects are the entities. So So like the pod is an entity. So like we are going to see like many entities here. So we are going to save that entities to the like our etc store, so that like Kubernetes know like what are the services it is running and other things. Yeah. So this is a like in Kubernetes we have like this much number of objects are there. Like we are not going to cover like everything. So we are going to touch upon like only the basic things. Okay. So yeah. So like in Kubernetes everything is an object. Like how to create the objects. So basically like there are like 2 ways to create the objects. So one is the using the YAML file or using the JSON file. So you can create these objects and you can post it to the Kubernetes cluster via API server. So API server like we have 2 ways of communication. So one is the like we can like a REST API. So you can hit the REST APIs and you can create all those objects, or you can use the kubectl. That is the command line utility, so that you can use it in the command line as well. So this is the basic structure of the like all the objects. So every object will have this API version, like in which APIs of the Kubernetes this object is introduced. So the next one is the kind. So what is the type of this object? So like in this example, this is pod. Then metadata. So metadata is the basic details about the object. So here it's name. So all the Kubernetes objects, like all the first 3 are the common one. So the spec, like the spec will change for like each and every object. Any questions on objects? Yeah, it's a pod object.
And you try to spin up a container using that image with the that is where you see the image. And you want to expose 8080 on that.
So next one is the replica set. Okay, so I have Docker, I have an image, so I can run it, right? Like why we need Kubernetes? Because we need the scalable. It should be scalable, right? Our applications. So for that, like I want to run a 3 instances of my application. So in that scenario, like I will specify the pod details and the number of replica sets. So if I set 3 as my replica set, so Kubernetes will take care of creating and running 3 instances of the pod, and suppose if any of the pods is died, so like Kubernetes will check for always listen for the number of pods. Suppose any one is died, like immediately it will create a new pod. So in Kubernetes, so I can run like any number of containers, right? Like I can run same instance of a single container, or I can run many applications as well, right? How Kubernetes know like what are the containers? So if in replica set, I'm telling like I want to run three instances. So how the Kubernetes know which 3 is really is my application? So for that, like they have a concept called labels. So basically, like labels are like a key value pairs. So in every pod, you will have a key value. You can add any number of labels. So suppose my application. So my application is a web application. So I am just adding application type equal to web. So by this label, so it can identify. So like there are 3 instances of web applications are running on my Kubernetes cluster. So next one is, any questions on replica set and labels? So yeah, so actually Kubernetes use like it is basically like it is labels are used to select the containers, right? So it is called selectors.
Exactly. So you use querying inside with the selectors. So that's how you find the root things inside.
So next one is deployments. So okay. So I am running an application. So actually I am running my application 1.0. So it's already running. So I want to roll out my 2.0 version in production, but without any downtime. So for that option, like Kubernetes giving this deployments option. So every time, like if you are deploying an application, so it will consider as a deployment. Like, okay, so then if I want to roll out a new version, so we are going to create another deployment. So it like basically like what it will do. So in this example, like we have replica set, so which is running a 3 instance of my pod. I want to roll out a new version. So I cannot kill all the 3 pods immediately, and I can create other 3 pods, right? Like there will be some downtime, right? So for that, what Kubernetes doing is, so basically like it is creating another replica set. So basically, like, and then it will create the 2 new pods with application version 2.0 and kill the 2 pods in the old replica set. So likewise, like incrementally, like it will kill 1 pod here and it will add another pod here. Likewise, like it will complete the deployment. So suppose something happened to my like in 2.0, I have a like a very big bug, so which will affect our application and users performance, everything it will affect. So I want to roll back to my previous version. So for that, like we can use this same deployments. So we can, if you tell like roll back to 1.0, similarly it will start doing it. So basically, like it will kill one pod here and it will create another pod there. So similarly, like it will kill all the pods and it will roll back to the previous version.
Will it not be like in an inconsistent state when this is
Yeah. So like there will be inconsistent state because it's a rolling update, right? In the rolling update, always like inconsistent state. But if you want to do a proper update, also you can do. Like suddenly you want to change like to the new version. Like all the users you want to move to the newer version. There is an option to do that also. Actually, there is a concept called services in Kubernetes, so it will take care of the load balancing. So, any questions on deployments? Okay.
I'm trying to understand because this is the proper use case for using Kubernetes. Let's say I have an application with proper 3 containers under the actual application, like what you gave it in Node, and it's just database container. Third one is the web server. Do I need to even consider this, or do, let's say the replica count is 1 in my case, but do I actually need to consider this technology, or can I just work with or whatever I'm doing?
Okay, so basically, like you don't need any replica set. Like you want to run a single instance. Suppose your instance is died. Like what will happen? Yeah, like Kubernetes, like will watch for the like always watch for your containers. If it died, like it will create another instance.
So if you are creating a pod, the deployment, okay, and if the pod crashes, okay, the state, so Kubernetes, the object is a deployment object, okay. So there's a pod inside the deployment So it goes back to the reconciliation loop. It has to maintain the state, so it will bring up the pod again. So that's the advantage of using deployments.
Of course, there's overhead of keeping a Kubernetes cluster up and running, and you have like only one application that has like only one database, one service. The complexity of maintaining Kubernetes cluster versus the benefits is going to be not if you are in public cloud like AWS, Azure, Google Cloud, then to take care of the complexity, right? So you don't have to maintain the cluster. So in that case, I would say that you can attach that. Right? So it's not that complicated, but still you can go for it because you don't have any complexity. There's nothing to lose. Right? You get the benefit. But say if you're going to be running this in a on-premise cluster, maintaining Kubernetes cluster running itself is like a full-time job or something. Right? That is completely not. There are so many other parameters like for this itself.
Okay, we'll see the demo. So I'm already running a Kubernetes cluster. It's not a cluster, it's a sort of cluster in my local machine. So I'm going to deploy an application with a replica set 3. So this is my Kubernetes object. So I'm going to create the deployment object. So here this is the name of my deployment object. So and I'm telling that I need a 3 replica set. Basically, like I'm going to I need a 3 instance of my I will share my screen. Pods. So in Kubernetes, everything is a pod. There is no container.
Yes. So the difference being, if you delete a pod, if your time is a pod and you delete it, the pod is gone. Right? So if you create the same pod with a deployment, it has to maintain its state. And if you say 3 pods, it's always going to maintain 3 pods. Time deployment is basically a wrapper.
So I'm going to create an object.
You will have replica set, you have other things, all cluster. Deployment is a composite.
Yeah. So yeah, this is the deployment kind of object. So basically, like it will have the replica set and as well as the pods. Like it will take all the configurations. Selector. So here, this is the label. So I'm going to tell this is my staging environment. So I'm adding this label, the template. Like, these are the properties of the replica set. So replica set need a container, right? So this is the container. So this is the name of the container. This is the this is my image. So this is my container port I'm going to expose. So we can ignore this one. So I'm going to deploy this deployment into my Kubernetes cluster. So yeah, kubectl is our command line utility. So I'm going to apply this configuration to the Kubernetes cluster. So I'm telling where is my configuration, like where is my Kubernetes object. Yeah, like my deployment is created. So before that I will delete my deployment. So I will show you like what are the running pods in my application. Okay. So these are the already running pods in my Kubernetes cluster. So I'm going to deploy a new application with the 3 replicas. You see here, like there are 3 instances of my application are running. Okay, like this things like you can do it via any application, right? So why, like what is the major advantage of Kubernetes? So I'm going to kill a running node, running pod. Okay. No, I can't kill replica set. So I have created only a deployment object, so it will take care of the replica set. So I'm going to kill a pod. So yeah, this end with DJR. Kill it. So if you see, there is immediately there is another container that created. This one is terminating. So before terminating itself, Kubernetes identified this is going to die. So it's immediately it created another container. So basically, if I don't want to recreate the pods. No, in Kubernetes, if something happens to the pod, it will delete that pod. So yeah. Okay.
If you delete the deployment, delete all the 3 pods created. So that is one way. That is, so if you created pods with a deployment, and if you're going to be killing one of those pods, it's going to bring it up, no matter what. Loop, right? So there's always a desired state, and Kubernetes always looks to satisfy the desired state. So when you what should we have keyboard here? Make it use. What should we I don't need how many deployment? Delete the existing deployment. Create a deployment with 2 replicas. But you change what?
There is no need of delete the deployments. You can change, like if you. So I'm going to update this file. I need only replica set 2. Like it will take care of the things. So.
But it will have the same 3 pods running, but it will delete only one of the pods,
Yeah.
and the remaining 2 will be running.
It will be running.
The entire thing is smashed on
So I'm going to apply this deployment. So I mentioned like I need only 2 pods. So say it's running only 2 pods. It's killed randomly. Yeah.
Leverage this to you can have an external watcher which watches few metrics from your application about number of requests, TCP, etc. Then you can use this technique to auto scale up or auto scale down. You can even script everything and you achieve auto scale automatically.
Is there a wrapper around the number of pods that we can put it inside the deployment? Meaning, I am running multiple services, each running on a different pod, and I want to make a replica set of each of these single. Can you just open the YAML file that you have? So what you have to do is just have 2 hyphens at top and bottom, and repeat how many you want and have it in single file. Or you have another kind called list. Okay. And inside the list you can have variety of other types. So it is just single file and the same apply command.
Any more questions?
Okay, we're running short of time. So we have another interesting interview now. Just take some time. So let's have a break now. Let's keep it short. Let's be back by 7:30. Or by 7:30. Let's wait. Alright, shall we get started? Cool. Thank you for coming back, my counter.
Is it coming in the Hangout?
Yeah, you can just select that. Yeah.
Cool. Okay. Somewhere done. Okay, shall we start? Cool. So this session is more about we have been using Kubernetes and Docker for a while, since 2014. So how you take your application to the production, and what you have seen is like a small training session, trying it out, how that works. But when you take it into production, you have more challenges. So how do you do the containerizing process, and then how do you take it to production? Do you need Kubernetes? Do you don't need Kubernetes? Or taking it there, what other pain points you have to face, and what you need to take care in a real production? Because we just out of curiosity try to run some product things in Docker, but when it really goes to production, you might not even expect these kind of issues, or you might not have made things proper to handle your problems. So this is more about a production journey. So I work in Appranix, and my name is Sujay, and I'm going to talk 1 minute about Appranix. It's not actually for any other stuff. It's to know what kind of problems are involved in the product. So that has made us to go through this solution. So we actually run a site reliability engineering platform where we help our customers run their production applications through our automation system. So anything happens in our customer's production environment, our tool has to ensure that it is running properly, fix it, auto scaling, and all these other stuff. We also provide something like a protection service where we take care of backups and restores and other stuff on the customer's production environment. So what we have done is like containers and Kubernetes since 2014. We worked in Kubernetes 0.7. It was not even in production, and every time when we try to do it, things break, because when you saw the demo, the API version was V1. So we worked with beta. So we went through a lot of pain in getting the requirements. Few of our requirements went into Kubernetes. So that's how things changed. So our product runs with 40 plus microservices, and it was all for earlier with VMs. So somewhere around it started with 20 plus in the virtual machines, and it was using all the auto scaling and other features, then slowly went into containers. So all you can take references. If any of these languages are there that you use, I can be in a very specific context in giving what kind of problem you face in the containerization process in that language. So we took source code from open source, and things were written from 2012. So our product is not 100% microservice. So we do also go through some monolith problems. So taking that to containers have few more challenges for us. So I'll be also explaining that in the process. So the takeaway is that once you should be able to see what you should do and don't do. How do you do an incremental change from your current system to Kubernetes without affecting your production, which is a step-by-step small incremental changes, and one day you will be on Kubernetes. So the other thing is, excuse me. So the risks you might face during this, and you might discover yourself, I don't know, it's just a journey. So before containerizing, these are the things that you need to be very much aware of. And we run Kubernetes for our customers, and we help them also to migrate. So the very common problem is that it is a marketing jargon: get your application on Kubernetes, containerize, we want to run things on containers. But the real problem is people doesn't know what their application is before they want to choose to run on container or not. So the very first thing when you want to do containerizing is that can you describe your application components? I have a database, I have n tiers, and these are these tiers, and how that runs on a VM, and is it something that are running in bare metal, where and how many process, and how they communicate internally, your networking, do you use any TCP communication or something else? What kind of communication? How frequently they communicate? So what is the HA and other stuffs already established in the existing system? So these things you need to be a bit clear. And the last part is one very important part. So which process stores and reads data from real storage, which means you have to write IO operation which writes and reads from the disk. So out of your entire application, maybe just the database, or maybe somewhere in the middle you are doing some file operations, doing some image processing and writing it somewhere and reading it somewhere. So these things you need to be very clear before you start with it. If you are not clear with this, you may not be able to convert. So caution, the other common problem we face is that containers are next VM. So this VM runs end services, get them into one container and launch it for me. A very common thing that we see, and that is something very common you could see as example from Docker hubs. It's not from the Docker, but most of the community projects, some people put it in the blogs and examples, you download it. One container itself runs MySQL, and it also runs a web server, and it also does some other process. So it's plenty, it's doing too much. So that's actually against the philosophy of containers itself. So one thing, so how do you need to see the container is it's actually a wrapper around your single process. So why do I need a wrapper? Going back to the original, it's the dependency. So you, how many of you have worked with PHP? Okay. Any Ruby developers? Okay. Anyone close to the operating system where you try to do any installation, you need to get more binaries for that. So GCC has to be installed and it has to compile Node.js. Obviously, you need to have some GCC and it has to compile. So let's assume that you take two of those applications on a single machine and you want to do an image processing. One uses some image library version 1 and the other uses a version 1.1. And now your system should have both the things on a single VM, and you are trying to run it. You have a conflict, the production is down, you have to solve somehow, and at last you bring down one application and you move it into some other machine and make sure it works. So this is where the container's real benefit is, wrapping that into that. So it is one process for which you get the wrapper along with it. So when I say one process, the next problem starts is, hey, I just have one process, that starts another process, and that starts another process. So this is something we frequently see when we hear about containerizing. Yes, it can do that. It is not, I wouldn't say that you shouldn't do that. If you take Apache web server, the HTTPD project, when you have request, it actually spins up more and more forks of Apache. So when you go into the process tree and try PS command and you see it, it will run 10 extra process. Or think about your Chrome browser. You open a tab and you go in and see, you will see four extra chrome.exe running in your machine. So that's, in those cases, there is somewhere one person, when you kill that, he will take care of the childs. So that is an acceptable use case, and that there is nothing wrong in that. There is another case where you start the MySQL and you also start the Apache or Tomcat, whatever it is, that's prohibited. You shouldn't do that. Let's go into the use cases slowly later, and this is one problem, and it's a caution. I say that if you have anything like that, please avoid it. So I think the other thing, if you have a question whether it can be done or not, you have this last point saying that when I do a control C on that process, how will the child process will be taken care of? When I give a termination signal, how that is going to be handled. If that process is intelligent enough to trace down to the last person and handle everything, you can kind of, it is acceptable to do that. If you are not doing it, then it is by design having some flaw. So once you want to get into a production, these are the questions that frequently comes to us. So can existing app work without much changes? I have an app, will it work, will it work, will it work? And this is kind of maybe, because we don't really know what is inside your application. So this is a maybe answer, case by case, we have to identify it. So will there be any change in the performance of my application? So there comes a couple of answers. One, I would say, yeah, there might be a boost. And on the previous talk, we heard about the kernels and reducing it. There is a performance boost. Yes, you do get it. Caution, again, it is based on your application, how you try to use it. So there are some problems in the Docker's networking layer and other areas. The way it handles the memory and other things, it may not fit for your application, or something that you have done wrong in your application is screwing it up. It might happen. So these are case by case basis, something you will learn only when you try to Dockerize your application. So I can give some heads up where it might happen, but it can go either way around. Can it cut your cost? Absolutely yes. I would say yes, it cuts cost. Cuts cost in various levels. The number of virtual machines, yes, it does reduce your virtual machines. Roughly 30% of cost cutting is happening, and it's even more when you optimize it properly. So how does it cut the cost on the physical infrastructure? Is let's go one step above into your virtual machine and then come back here. When you have a virtual machine, you buy the RAM and the CPU. The hypervisor shares the CPU, but it can't share the RAM. The RAM allotted is rigid. Yes, VMware and other stuff, they provide the ballooning and the features to handle the RAM, but there is a physical wall for the RAM. So you have 8 GB of RAM. You have to only allot within that. You want to do more, it's like using your page file or other systems where it will definitely slow down your system. So let's take two machines. One has 50 to 70% of RAM free, and there is another machine which just has 70% of RAM consumed and it just has 30% left. So you merge them together, you still get a lot more RAM free. So this helps you to do a lot of cost cutting in your infrastructure, and that's where containers help a lot. On the infrastructure side, the invention is actually you share the RAM in a bounded way, which was not possible in the previous VM world. So how do I debug logs? This is the next challenge. That it's all good when you do it in your local development and you can do the developer debugging stuffs and everything. But when you take it into production, now it's not like one process in one machine, it just moves across multiple machines. Whenever something goes back, let's take a case that your application starts and it just terminates. Because of some configuration issue, it just exits. So if it is one VM, you go into the VM and you just try service start. You see the log. Oh, this is the problem. Let's go and fix. So what happens here is when you try that, let's take the case of Kubernetes. Yeah, you kill here and launch it in the next machine, and then you go there. You will not be able to trace it. It just keeps moving across machines. If the cluster is huge, obviously it will start moving across the cluster. Tracing that would become a bit more hectic. You need to have the systems in place to do that. So how do I back up and restore? Do I really need to back up my container? No, you don't need to back up a container. You have the registry, you can just spin it up whenever you want. But then where do the backup comes? Yeah, the storage. Then do I need to run my storage, whatever my persistent system on the container? The chance, it's again, do you wish to? You can. And there are ifs and buts. And if you do so, again, your backup and other strategies also fall into it. So how do you restore? What happens? Your entire Kubernetes cluster itself has gone. Just as an explanation, if you erase the HCD, the cluster is gone. You have to get it back. So how do you get it back? I don't care about the cluster, but I just care about my business application. It has to run somewhere else. So maybe my shopping cart or maybe my website, it's running there. I don't care whether it is in the Kubernetes or not. It's gone. Now I need to run back in some other systems. That should be a process. So then comes the monitoring. Bits and pieces you heard in the previous session that you can do auto scaling and other stuff. Kubernetes also provides some features on the monitoring part, but leaving Kubernetes aside and you want to go into monitoring, you still need to do some more work on it. So how are you going to do the monitoring? What containers can provide by themselves? What you need to do for tools? These are open-end questions. Then what changes in my security? Yeah, this is another serious questions that we have been hearing from 2014. So lots of bugs have been fixed in Docker itself, in the container, in the kernel, Linux kernel. There has been tremendous change. Kubernetes have been hacked. A lot of security features have come in. Multiple stuffs have happened in the recent years. But the reason why the security is a very serious concern for many people is that you share the same kernel. When you have a VM, you have multiple kernels and one VM got hacked, definitely the other one cannot be hacked. The only way to do it is you go into the hypervisor is compromised, and then you have to come back to the other VM. That's the only possibility in the VM world. Something like a Spectre, that recent hypervisor bug that came up along with the Intel processors and other processor where the memory can be hacked. Yeah, there are some exceptional cases, rarely that occurs, but in reality, hypervisors are very tough to hack through, and it is very rare scenario happening. But when you do it in containers, the possibility is quite high. The bugs are there, and it is getting fixed, and it is lot more better now. Yeah, it is happening in production, and it can protect you. So there are considerations you need to follow to ensure your application is secure. So now it is not the containers, but it is your application process that you need to take care. So to start with, I'm just going to take a simple 3-tier application. I'm not going to do any demo. So it is more of a conceptual understanding step by step, and then we will go through some use cases. So to make sure we are on the same page, it's an Nginx with an Angular application, and then there is a Tomcat and there is a MySQL. So the Nginx serves your HTML or your front facing web application, and the Tomcat is connected through a small reverse proxy, and you could see the proxy configuration. And the Tomcat actually runs some Java application. Let's keep it simple that one of the property file is here, and you could see that it is connecting to the database, and this is quite simple. And then the last part is your MySQL, and then MySQL has one part that I have noticed is the data directory where the MySQL is writing the real database. So the file where you can find your database. So this is a simple application and one large VM, and it runs, and most of us might have is familiar with this kind of setup. So if we try to containerize this, how do we need to move forward? That's how I'm going to start. So any heads up, anyone who has done this already, this kind of anything, maybe Tomcat versus something else, anyone who has tried it? Yes. What's your setup? Okay. Okay, got it. So you are running everything on Docker now, or just a VM? Okay, got it. So here's what we are going to do. The very basic step is to containerize each application, and you ensure that they don't come into a single container. And I leave that part, like how do you create the image and how you use the Docker run and other stuff is left there. But once it is converted, I am actually trying to keep my configuration files as it is. What we saw here, which is the local 127 loopback and the localhost loopback, I'm just going to keep the loop as it is, no configuration changes. And I want this to work in my container. That's my very first step. So what we are going to do is, when we launch or run the container from the image, the one thing you need to take care is the network hosts. In the Docker, you just need to make sure that you are giving the network as host. So if you try to understand the layer behind the Docker or the container itself, the file system layer is unique per container. But there are other namespaces which can be shared. I'm speaking about Linux namespaces, where it can be process, it can be network. And each container has its own unique process, so they don't share the process namespace. So if you go into that and give a PS, you will see in each container one process ID will be 123. You will not see some random number, but you come back to the host machine and you give the PS, you will see it running in somewhere around crossing 100,000 or maybe more than 50,000. So what is happening is actually each of the process that is running inside the container is actually a process in the host machine. So that's one reason when you were asking about the question that is it the OS, I said no. It's because it's just the runtime libraries. The OS is really in the host machine. It's not inside the container. It's just the binary dependencies that it needs is wrapped into it. More like a tar file. Just assemble all your static linking and then make sure it is running. So it's kind of, that's the approach. So the real process is running in the host machine. So you do the PS, you will see that, but the process ID varies. So that's the process namespace isolation. So the next one is network, and each container gets a new IP address. So that's the default when you do it in a Docker run, but that's where I have overridden with saying that network is equal to host, which means you can't do a port mapping. There is no -p switch that we saw in the demo. No. So if any port opens in one container, that is going to open the port in the host machine. So that port is exactly mapped, which means none of these three can share the same port because everything is on the same IP address. They share the same NIC. You do this, so localhost, this can connect to this as localhost and this can connect to the other one as localhost, and things work. Your application is decent enough to run in container. And you will not see any performance difference here. You will not see. The reason is the major performance issues you see is through the networking layer, and we have trimmed it out. So there is no network extra cost over here. So this is the level 1 we do. Any questions for this? Usually varies. That is when you don't say the network is host. So it picks the host's IP address. So when you go into the container and you try to do the IP address or anything, you will see the network interfaces of the host machine. Literally, you don't get the file system of the host, but you get other process constraints of the host machine.
So does that mean that you can run only one instance of one container of Apache Tomcat?
Exactly. You can't run two. In this, you can't run two. So I'm just taking one step at a time. I'm not running fast. So you can ensure that your existing application is just, you had it in that way in the VM. Yes, I agree with that.
So you need to run another container saying that if you want your traffic to connect to your web app, so it should handle it like something of the sort. It's similar to how you run to Apache Tomcat and then manage the traffic to it like that. It's exactly the same. You have just packaged the file system, created various that you go, the static links, that any SOFI that is required for your app, you have just built all around it in this step. Okay.
So it's kind of like you still have the same VM and things have changed a little bit. The benefit you get out of this is that you continuously start releasing your existing build pipeline through containers, and it is on the same machine. You have a new release process for containers, and you haven't disturbed your external load balancer or whatever the configurations you had. Things work same way and you feel comfortable.
It's like, we manage all these things through Kubernetes.
I haven't even touched Kubernetes. We are still with the plain containers, and I'm going to go step by step, and there will be a point when I'm stressed, I need Kubernetes. Then we'll get into Kubernetes. Okay, the same case, we have already done the isolation with the VMs. I have 3 VMs, I don't worry about it. Do I need to go with the same stuff? Okay, in this case, your existing configuration should somewhere look like this. You might have a complete domain name or a small short name, and it should be connecting with each other. Maybe you'll be using your IP address to connect to each of the hosts, and this is a common configuration that you will see. So when you are having this and you want to do it, I will say repeat the process. You have the same thing. Each machine has the same thing with the same host, one container in that. That's it. So why do I want to do this? Let's make sure that our existing application is not bringing any new complexities for us, and our existing production pipeline is not facing too many problems because of containerization and Docker issues. And heads up on this, you get the benefit of your OS patches. The IT team is free to do the operating system updates, and your application will not be impacted. Maybe just a restart time, but you can believe that it will not disturb the dependencies. You don't need to go through a rigorous testing there, except it is not disturbing your Docker. So that's a huge advantage you get with this system.
So in this thing also we are creating IP inside host. So we need to do that because in the existing setup we had different IPs. The network, it was running on a different network, but we are creating it on the same network.
It is on a different network. For this machine, let's take the Angular application or Nginx. It is just taking the same IP address of the host machine.
That's what I'm asking. So do we need to do that, or it can, just it can create, each container can have their own IP?
I would say that take it as a step 2. I don't say no to it, but that try it out as a step 2 if you have your configurations to handle it.
Because the existing setup, I had it that way. It's not like should I? Can I do it the same way that in the container as well?
Yes, you can. You can. So if this is properly done in this configuration, if your existing setup is like this and you are doing this small change, you can actually bring them together on a same machine.
The probability that we can have the different application running in the same port, then if we convert it to the container, it will lead to problem.
Exactly. And it is not just that. We have seen some other third-party applications running on the host machine that is connected to this, and they are doing something with that. So it's not always we think that it is only that application. Tomcat I am moving, and it is the Nginx I am moving. But maybe there is another application in the same machine which is also part of your application, and it is trying to do something. So it is because we went through production changes of applications which even the customer doesn't know. So it's a very cautious, slow approach. Even in this, things will break if they don't share the file system between those. Let's take in this case, the file system has changed. There is a location from which that external application is trying to read that doesn't have the access to this one. So this happens quite often if you are trying to do something like that. So that's the reason I say try it with this. If it is successful, cool. Then we'll go to the next system. Put it everything in the same machine. Now you do the Docker thing and try to do with a link. So before that, here are a few things that let's ensure that properly configured in our containers. Use DNS names, and in that don't have hard complete FQDNs, that is x.y.z.google.com, some full names. No, within your application. If you are accessing a DB, don't try to have a full domain name. So how you can handle that is always trim out your application into one subdomain and connect within them using one small service host names. And what you need to do is keep the rest as your search domain or your root domain for the container. So if you could do a little bit tweaking in your DNS, you get that benefit. So the same works inside the container without any trouble, and it also works outside the container. The environment variables, and this is where you usually pass your configurations, but nope, it doesn't work all the way, always the same way in any of the production applications, because the existing system is not written to read from environment variable. They will read from files. Yes, you have to do volume mount for the files. If you want to tweak it better, so find some environment variables, read it, and before you do a launch of your application, go and templatize your configuration file. So before start of your application, it reads the environment variable, parses your configuration file, places the environment variable values there, then start your application. It picks the new environment variable based values. So this is one approach. There are files like dockerize command. You can get it from GitHub. So that would help you to do that step. So your existing application still reads, you just need to do couple of steps for the file parsing before you launch your application. So the last part is how network intensive is your application. So going into this, I would like to go into two of our production experience. One is we were trying to run a service very similar to RDS, Amazon RDS. So it is actually a database as a service. So we provide the database to the customers and we are responsible for upgrading the database itself. So, and there is a very small window for us to update. And how do we manage it? So, and this is very specific to MySQL and Postgres, but not to Oracle or anything. So how do we do this? So what we did is the very fundamental problem is OS patches has to go frequently, and it is all, we are always afraid that that goes in, it will have a trouble. So the same host configuration what I said was used for the database configuration, and it was writing to the file system which is of the host machine. The storage was really attached to the host with a greater IOPS. It really went into the SAN. So whatever was really provided and some local storage and all these things, it was exposed, and just through a volume mount and things were working fine. And whenever we want to release a new patch version, it was in milliseconds to seconds, things should be back to fine. So the update window we provide to the customers were less. So this was a kind of a POC, and it was all tried out and taken by the other team after that. So this gave us a couple of hints to us that host networking configuration is better when you have heavy network workload. Why? Because the way Docker network works itself is CPU intensive. So it goes through the CNI layer, everything works with our IP tables, forwarding rules, NATing algorithms. So that takes a bit of CPU intensive work. So quite normal in a normal application, you won't see that. But when you serve something like a database and that runs on the machine, then you need to be very much optimized for the network loads. I can give you another example where it is a collector where it collects monitoring metrics and then it sends to another server. So it's basically a monitoring metrics collector, and it was well tested in the product development. It all felt good, things were running fine, but when it went to the production, it was a surprise for us. They tried to merge all the containers on a single machine for the customer deployment. So the surprise is the data was the real data. What was the test data was different, and the real data was a bit heavy. Each request was giving around 14 to 15 MB of data, and this collecting logic, it was even with multi-thread or whatever it was done, it was in a frozen state. The real problem was not with the logic it is written here. The Docker's NATing took too much of CPU. So the rest of the applications, other shared applications were trying to take too much of CPU. So just, it is not the application, it is the networking layer that was taking too much of CPU. We didn't know. You do the top and everything, you will not see anywhere else. So it's somewhere gone out of your calculations where it is. Change it into host network, let's try it out. Things worked. It was the NATing algorithm. So since we have worked with routers and other stuff where we do this stuff, we know the CPU a little bit where it could do. So it was a easy walk for us on that day. But in reality, you will be thinking that what has gone bad, it is all containers. You just need to switch this networking layer. So do I need to do this or no? That goes to your previous question. The ports, conflicts, are you ready to handle it? Do you really want this much of benefit? Then go for the host networking, else don't go for the host networking. Scaling challenges. Yes. Okay. Scaling challenges. So there comes the next problem. You can even run in a Docker Compose. You can try to scale everywhere. You try to scale, but you really need a load balancer and things have to be done. And obviously, this works perfectly on the web layer, in the application layer, and when it goes to the database, yes, you can't scale because you need to have your storage in one machine. Storage doesn't copy everywhere. So the entire SQL I would put the RDBMS transactional databases have this usual problem. So you need to think through how to handle it. And Docker doesn't solve your problem. It is something you need to come up with a different solution. So people sometimes even try that my database is slow, can I scale it? So you need to upscale it by increasing the CPU. So we would recommend that keep that in a different machine. And this is where the real VMs play the game. You don't use for these kind of things in a container. Keep it in a different VM where the storage and everything is completely optimized for it. And it can perform enough for your production load. So don't bring it in. It is okay for your QA applications and other stuff where you can take it into the Kubernetes or maybe into your normal developer machine with containers. That's good enough. But for your production, caution. Logging and tracing requests. This is another problem. So even in running with a plain Docker, we do have challenges with the logging feature. So centralized log management is always a challenge. You run with multiple machines in a cluster, then logs goes into each machine. Customer gives a one page where it has 5 AJAX requests, each goes in a round robin into a different machine. You can't trace that one customer's request. So obviously you need to have something. It's not containers, but it is distributed. So you need to have something like a Zipkin or open tracing, some kind of mechanism to get that. You can even do that with the log tracing also. Again, leaving that to Splunk, ELK or EFK, whatever it is. You have some extra tags to trace each request, send it out and then filter it out. So this would become more tedious when you don't know where your container is running. So this is expected challenge. So this is what a normal, wherever you see beats, it's just a Logstash client. So don't get, if you are aware of the change, name change and new product, it is okay. So it's just a Go binary, reads your file and then sends out. So let's take this Apache Tomcat is running and it's writing in the catalan.out in a normal VM, and the beats is used to read that and then it will send it to Logstash and Logstash will send it to Elasticsearch. Now you can put a Kibana, do the search. This is what will be happening in your normal use case. So think that if I containerize this, what will happen? So this is where the problem starts. So the logging becomes a challenge when I try to containerize this. So do I need to have beats into the Tomcat? No, it's forbidden. So what should I do? So we need to go through some challenges. So if you read through the Docker's rule book, you will be hearing that, oh, you need to always put the log in the standard out or the standard error. There is no really log file system you need to write into. You just need to push it into this. Oh, really? Yes, you need to do that. Docker will then connect to a log driver, and that log driver will again connect to whatever that third-party logging system is. Maybe your journald or system logs. It can push into that, and you can do your existing system to take care of it. Yeah, it all looks fine, but the problem is real production application doesn't use one type of log. Let's take even in Nginx, you have an error log and you also have an access log. So each has a different type of format, and parsing it out and bringing it has much more complexities. So you cannot take it into the same Logstash and do all the grokking work in it, super complex grokking work on top of it. You need to have them in a separate way. So the right way is to put a volume mount, now you have multiple files. And challenge starts.
Simple line for log statement. Give a structure to the log. Usual format that is followed is the data.
Yes.
So instead of following a simple write a simple line, you write a data. So data has a start tag and tag, it has the key value. So even if two lines in a data string are different, you can make enough information baked into each of the lines. Your log parser can be, very simple to read and understand. Structured logging itself.
Yes.
Please don't know all of
I'll go with few more challenges with it. Structured logging, we use that structured logging for Rails application. We also use that for our Spring applications where it is easy for us to do. And there are applications where we couldn't add that. So the caution here is that we couldn't add it. And what we need to do for it. Now comes few more challenges. I'm just going to go through a couple of options on it. And if you have structured logging, I always prefer that, because you really don't need to have extra CPU load for your machine. You still have a very optimized setup. If you can't achieve your structured logging, then these are other alternatives. So either it has to be in the host or it has to be on a container. So if it is on a host, then think about sending it to the host through the log driver, and it is written, or through the volume mount, it goes through the log driver in a specific path, in a specific pattern file name. Then something is there to read and rotate it, clean it out. So that has to be done on the host machine. So how that you need to do, that is an organizational preference. Companies have different approach for it, so I can't step into it and say you have to do it only this way. It's not an opinionated approach. Or the other way is, the application will have another sidecar, where the logging itself will not be written into the real disk. It's a temporary space it is writing, and the sidecar will be just sending it out, and it will be cleaning it out. And it's quite CPU intensive, because for every instance of in your pod or anywhere, you will have another sidecar running along with it. So the challenge for us is it has to have a shared storage between the containers. One app where it writes the log, the other is reading it and then sending it, and that will be another container. So you need to have a shared space of storage. Pretty complex. Setting it up is complex. It looks easy if you do it with some Docker's internal configuration, and it looks easy. But when you scale with multiple machines, you will feel the pain when it scales. It's not when you see it in the very first few days. Obviously, you need to bundle them and deploy them properly. And I haven't even touched Kubernetes. So these problems are very specific to plain Docker and containers. So bundling those two containers and running it, and sometimes you need to have something like a port listening within the containers to read that and push it into another system. So this is where you need to do something in Docker like this in the bottom, where you run your app, you get the ID, and you go to the next run. In that you say network container, and then you give the container's ID or the name. So they both share the same network now, which means the same IP address. The second one doesn't have another IP address. The second one shares the same IP address. So they stay in the same network, so they can't share the port. Now this can read through the network protocol, localhost or anything from that, and then push it back, whatever it is required. These are few things we have done with no other way for some logs that were captured through the HTTP request. Don't ask me why did they do a HTTP request to the application to get the log. That was an implementation, and we have to go through that. Okay, so when you do this and you want to scale with a cluster, you will feel the pain every day and night in solving this, and that's where you need Kubernetes. It's not just this, much more. I haven't touched the storage part. I have just left intentionally, maybe in the last slide. I just want to know the time. 8:15. Okay, I'll try to be like 15 to 20 minutes, and the next part is going to be even more condensed. I want you to raise hand if I'm going too fast, and we need to I want to trim out the content or anything. I just need to plan based on it. Okay. Open. You just need to just raise it. That's it. So when you get into Kubernetes, the big picture as a Kubernetes administrator or a developer who is going to spin out things into it or configuring it should be aware of two things. What is a cluster scope and what is a namespace scope? So when you speak cluster, it's like you think in the infrastructure world, VMs, the host machines, and what is configured for it, the storage for the entire cluster. It's you buy storage and you put it inside somewhere inside the cluster. So that's how you need to see that. And it is purely the infrastructure IT team that's how they see 100 machines, that some TB of storage, and that's how the cluster is seen. And you want to do it for every storage or network throughout the cluster wide, you see it in the cluster scope. And when you go into the namespace, namespace is pretty much your environment where your application is isolated. So you have CI, QA, whatever your integration QA environment, UIT environment, each will fall into one namespace. So namespace is a kind again in your Kubernetes application. So namespace pretty much keeps to your application level. Cluster is your entire host machines and other stuff. So using pods to bundle, I took this example so you might be easy to understand this, but again going back referring to Selva's comment, don't do this, keep your application clean, but if you want to do it, and this is the way to do it. And exactly. And the other way is that you can start with this on your refactoring, slowly fix your architectural issues on a slow pace. You can remove these things and bring efficiency to your existing system, cut the cost, whatever it is. So step by step, not everything on a single time. So here what happens is you see that two containers, one is Apache and Beats, you put them together in a pod. So when you scale the pod, both the containers run along with it, and in a pod, the pod always runs on a single machine. It doesn't run on, you have two containers, the two containers will never run on two different machines, they will always run on a single machine. So they share the real CPU, memory, network, everything on the same machine. So now, this is the way that you can connect these two, and you scale, obviously it scales. And in the pod always shares the IP address. So pod is somewhere comparable to a VM, I wouldn't say that it's a VM. Why I said that is, you get the IP address and that's where you ping or do is for the pod. You don't actually connect to the internal container. So it can have more process bundled together, and that's how the pod works. So let's take a case. You have two host machines, and this one is using the daemon sets. That's another item that you saw in the previous session. The daemon sets usually tries to run on each node of the cluster. Daemon sets don't run in namespace scope, they run in the cluster scope. Obviously you can, everything is attached to some namespace, but you have the cluster wide stuff. So this application, somewhere you put it in each host, so it can collect all the logs written on that host machine, collect it and push it out. That can be done through this. So you want to run Beats on the host machine as a normal service, and you don't want to do Kubernetes, that's a different story. You can choose your choice, but this is the way you use a daemon set to do these kind of work. And pretty much the other problem we always have with these kind of volume mount log is that someone has to actually rotate and clean it. People think that only you do volume mount and then the Beats sends it, don't has to clean it up. No, you need to again write a process to clean it. You don't have a choice. You have to clean the logs. Okay, then comes health and auto restarts. So when you try to do a Docker run and your application has a health issue, something your script is wrong and it exits, basically just terminates and comes out, you will see that it has exited. You will not see the Docker process running. But when you go into Kubernetes, you will see that it is starting again, it is starting again, starting again. It is nothing new. Docker has all restart always. There is a feature called restart, and you can give always. When it exits, it will just start. And that's a de facto feature in the Kubernetes. So all the containers are with the restart. So the problem is it restarts, it switches from machine to machine to machine. And if you don't have your logging system, you can't trace that. So you need to have some mechanism to stop somewhere. So that's where you need to say 3 times stop. Those configuration has to be overridden in your spec file very clearly. Try 3 times stop it. What you need to do, because Kubernetes mostly tries to achieve through the reconciliation process. If you say you want 3, it will try whatever it takes to bring the 3, and it will keep on trying even if it is not possible. So you see that it is just jumping here and there. So there comes two things. You also can control it a little bit. You can have liveness probe and readiness probe. The exit is something considered the process has terminated, so it will start again. But think about a process where it is in a frozen state. Maybe something is hanging in the infinite loop or something went back. We started with the Rails application with a single thread. We didn't have a choice when we converted into a container. When we tried to do a unicorn, I forgot the library name. We tried to do this multi-threaded approach, but the old code was written not to support the multi-threading. So awesome code. So we were forced to run in a single thread server. And when we started doing this single thread server, you open a browser and a hit goes into your cluster. You run with 5 containers or 10 containers. One page will obviously block 3 containers, each a blocking request. And if 5 people try it, all the number of containers you have will be blocked because each is running with one thread. And this is a huge pain for us at that time. And what happens is we had this liveness probe and readiness probe for it. This is going to make a fun for you. It can only serve one request, and the liveness probe is actually a curl command. It goes to it and then asks, can I get the request? Is it healthy? So it just expects a 200 status OK. So what happens is now it is already blocked and it is not able to respond. Kubernetes tries to wait for it for a while, the timeout happens, restart it. But actually it was doing a CPU intensive request, and each time it was trying, some other request came in. So the Kubernetes started to kill it. So now the problem went into a different style that the user who was seeing always used to say something happened, error, some error occurred, something went wrong, something went wrong. So you started seeing that too much of issues on the UI. So you need to tweak a little bit on the liveness probe and readiness probe based on your applications, these kind of issues. And this will help you out. As Java application might take 30 seconds or 1 minute, or sometimes it might take 3 minutes or 5 minutes to boot up. So you need to put the initial boot time, then this shouldn't go and poll within that. So that's where your readiness probe comes in. So how long it has to wait for the first time to serve. So these based calculations, and this is very important when you are attaching it to a load balancer. That's where the challenge starts. You just add it and you don't have a liveness and readiness probe, it's good. But when it starts, and even if it is not ready to serve, the load balancer will send a request to this. So to add it to the load balancer, or the load balancer should be intelligent enough to detect whether the application is ready or not, you need to have the liveness probe properly configured. So if it is not ready to serve, it will not be attached to the load balancer, and you are healthy enough in serving your customers. You will not lose a request. So there are some configuration in this: success threshold, failure threshold, and you will go through that to manage this. So the other part, very critical in the Kubernetes world, is service, load balancer, and the service discovery. Yes. So what these are, service is yet another object in Kubernetes. You just go and get it up. So service is the internal load balancer inside of Kubernetes. What really happens is service has an IP. It maps to a DNS name, and it gives the endpoint for your application to connect. So in our previous case, you will have a service for the web, for the app, and for the DB. Whether the DB stays out or inside your Kubernetes, you might have a service for it. Keep it in external connectivity. You can take it as an external service, and you still have it as a service, because internally everything connects to that through using this load balancer, and it goes out. Since it is a load balancer, caution, don't delete your service. Why? If you delete your service and recreate it, you will get a new IP address, and load balancer's IP address should not be lost unless otherwise there is something very serious that you are going away from it. Reason? Load balancers are bound to DNS, and why do I want to worry? My DNS will take care of it. Sorry, not all your clients are sensitive to DNS time to live, TTLs. So they will cache it and they will keep it forever. The TTL might expire, but your client keeps it. So it will still connect to the old load balancer's IP address. So don't do that. The next thing is when you play with this services, there is an exposing a service, means you make it available outside your cluster. So far, whenever you have anything, you go into the cluster and you do the curl command or whatever your command, you work within the cluster. Anyone who stays out of the cluster can't access your application. So the only way that your application can be accessed from the outside world is exposing a service. And when you expose a service, obviously it opens a port. And there are three types of port: host port, node port, and then you have the other option is called load balancer. So wait a minute, we are speaking about service, and service is a load balancer. What is this next one is load balancer? Technically speaking, load balancer internally uses the same node port, but also triggers to a load balancer configuration where your external load balancer can take the trigger, connect back to that and configure itself properly. So when you are going to connect to a real load balancer, you have to use that, and you need to have proper configurations for it. It is, if the system is not really connected to a load balancer and you give a load balancer, it will not fail. It will just open a node port and it will leave it. That's it. It is not going to disturb you. So what is a node port and what is a host port? If you are hardly bound to each node's physical machine's one port, say 80, and if you want to only take the same 80 in all machines, then it is host port. The host machine's port. So you do a port mapping to the host machine always on the port. You don't have range or anything, so it is bound to that. The node port is something that is a range of port which Kubernetes can assign on random. So you will give 32,000, 50,000 to 55,000. I give 5,000 ports. Yeah. Any application you launch with an expose, obviously it will get any of the random ports within that range, and that's a node port. So node port is always a better approach here, and ensure that your load balancers are properly configured to connect to the random generated node port. So that's why you use the load balancer automatic configuration, because each time you try to expose, it might give a random port. So other than that, yes, the load balancer, the service inside the Kubernetes tries to do a round robin. So maybe the round robin might not be a fashion that you want to solve. And the reason is that in the round robin, it is already a single threaded application and it is locked. You don't want to use it because you will use another thread. So you need to have another strategy to do it. So yes, you can do it. Kubernetes provides APIs where your service can connect to Kubernetes and query the Kubernetes API server and get who are the real machines connected behind the load balancer. I mean real containers, pods behind the load balancer and their endpoints, and you can do a client-side load balancer over there if you want. So this is the way Nginx, which acts as the ingress controller in Kubernetes de facto design itself, is using this model to serve. So in that, again, readiness probe and other things are also applicable. So you need to work with the API properly to handle it. So the last part is the ingress controller, and ingress controller is very specific to HTTP and HTTPS based services, where you really want to have one URL for your application, example.com/microservice1, microservice2, microservice3. So kind of an API gateway, map it to some service and the port. So ingress controller has the YAML, it automatically takes care of the rest. So this ingress controller will run on every host machine, the real host. So if you have the IP address of the host and you connect it to any one of the node and then you try it, you will be able to access it if you have the proper DNS configuration. Or you put a real load balancer, connect every host machine to the load balancer and access the HTTP and HTTPS, it does work. So that's service LB and service discovery. The last part is the storage and the Kubernetes. Highly recommended. Caution with the storage. If you are good at managing this, you can proceed. If you are not that good in understanding how the storage works and caution over here. So you have two things like a persistent volume and persistent volume climb. So why I said the cluster scope in the early stage is that the administrators buy the hard disks and add it to the cluster. Let's take a case in a physical world. You buy the hard disks and you keep it in your storage When someone asks, I need 2 GB or 1 TB disk, he takes one and hand it over to that person. And that process is called a claim, storage claim, volume claim. So once you claim it for some of your application, now it is being occupied by you and you have your data into it. So I should never give that to another person. So it's a claimed volume. So there is a storage process involved in this and how that works. The tricky part is your application is gone, you are not at all using, you have turned it out, it was a trial of test and application, and now the storage volume has some TBs of data. Maybe not, but I gave a 1 TB disk, it just stays there and costs me. Now I have to take a decision whether I have to delete it or leave it there for a while, so you can consume it later. There goes storage policies, whether it has to auto delete, when it is a developer or it is a production application, we have to keep it. So those goes into the Kubernetes storage policy, it manages it very good, but you need to configure it well and good to start with it. So let's take a case, the storage is always attached to a pod, not to a single container. So this is one of the reason I was saying it's kind of comparable to a VM where you get the network and storage on a single machine. So this gets to the pod, not to the container. So what happens is you launch a pod and the pod does a volume claim, it gets it and you run your MySQL. Yes, it works perfectly. When you don't want it, you can delete it and do all the operation, no issues. But now when you want to scale, scaling for a MongoDB kind of application is quite different. It's not the same. Forgetting about the VM world, I'll ask few questions to understand this problem. MongoDB has two parts, it's shared and the replicas. So if you have 3 replica, 3 shards, you will have 9 machines, which means 9 storage has to exist there. So I can't just like that go and say increase my replica. It really consumes the storage and this works in a different way and the shard works in a different way. So configuring this and keeping behind a service requires a different algorithm to work with. So that's where you see the stateful sets. Stateful sets are like the replication controller for storage. The way it works is quite different. In case of a normal replica set, when you say 3, it will launch 3 pods in parallel. But when you do in a stateful set with a replica set 3, no, launch 1, make sure that is successful, go to 2, go to 3. The reason is you will see it even in the numbering sequence. The pod name will be alphanumeric keys will be generated for it. But when you get into a stateful sets, it will be 1, 2, 3 with a proper numeric index. Reason, when you shrink it, the last has to be retained when you again scale it. So the replica reduces and replica increases, the same storage has to come back. So this is the complexity and that's also managed here. Okay, the last part, I wouldn't say last part, I still have one last slide. Security, this is a concern that we frequently hear to it. So test with following things in your existing Docker images. So see that whether your application is compatible with it. Make one of the flag in Docker is to make your root file system read only. Do that and run it. You will see where it is writing. Our Spring Boot application was using FlyWayDB and it was using trying to read the SQL file and write it into the temp directory and then execute it through the MySQL system. Surprise, we thought everything is fine. So you will see some surprises like this in your application. Your application might not run when you make it into read only. But if you can do this, any hack attempt that happens to your container will not be, any script cannot be written into the container using an injection. The file system access is locked to the attack. Volumes with read write or read based on need. So let's take, we went into the logging system or something else where we downloaded, write it, read it. So if one container wants to read, make sure it is only doing a read, not a read and write. So your file system is properly protected. Use config maps and secrets to avoid exposing passwords and send. So the way we saw in the first step is any configuration is passed through the environment variable. So when you do it in Kubernetes, you still do the environment variables, nothing changing because it is still the same container running behind. But let's take a case, you want to change your database password. The developers have to key in the database password in the environment variable. Do you really want to do it? Do you want to keep it protected that it is not, it goes through your Git at last, someone can read it. So what can you do? So the normal deployment will use config maps and secrets, and a config map and secrets might be belonging to a different repository or a secured area where they enter it, and that is deployed. So kind of this is namespace scoped and cluster level that you need to manage it in your way. So this goes to the administrators who decide, okay, here are the secrets for this environment. Only this secret is exposed to this environment, and if I change the database password, I can just get into that secret map and I change the password in the secret map, roll out a restart, things should be fine. That's it. Run container as a non-root user. Kindly test your application. The last demo was with the root user. You might not have noticed it. You don't even know that, and that's how all the containers run. It takes the root privileges by default. So try to create your own user ID, -- user ID, 500, 1000, 2000, 7000, something like that, and run it. You will see exceptions coming. The same Node.js will not be able to install it, so the installer will use a root privilege. The image will be created with the root permission, but when it runs, it should run as a different user. The same thing that we use in the VM world. How do we have a production application running as root? No, you have a different service user and that user uses it. Why? The memory inside your system is isolated to that user, so he cannot hijack into the system's space. Once it enters the system space, it has access to everything. So you need to isolate it through the user. And how do you do that in the container? Use it this way. If you want have a series of 10,000 plus to 10,500, all my applications will use different numbers. You want to track it down, you can do that. Kubernetes also takes care of file writing privileges. So if you have a shared storage between two containers and they use different IDs, user IDs, it also provides a group ID to read, like how we do it in the normal Linux file system. At last, the ACL, in the real world, we used to put a physical network isolation for each of the teams, and this application should only go there, put the router or firewall between it. Only the web can connect to the or app can connect to the database. No other machine can connect to it. No other service can connect it. You gateway that, put the firewalls, all these configuration. When it comes to Kubernetes, the basic rule in the Kubernetes pod networking is any pod should be pingable to another pod. That's the basic rule in setting the network. Oh, then how do I have a multi-tenant setup? Yeah, it means that how you want to have the network's basics, but it doesn't mean that you can put the restriction. You can put the restriction, and that is not available by default. If you use Flannel, no, you don't have that. You need to go with Calico, Canal. Calico's commercial provider is also there. So you have multiple options, Weave Scope. So you have to choose one and go with it where your network policies can be applied. So the network policies are by default a Kubernetes object. So it looks, oh, it is already there in plain Kubernetes, I can apply, but internally it will never apply because your implementation layer should have that networking feature. So the choice, why do you want to go to a different networking implementation, is for the security reason. And it also provides some performance boost and other stuff. And the node port range and host port range, as a cluster administrator, you can choose what ports should be exposed and what should not. Control it. Don't let the developer's namespace occupy some system ports. So block the host port feature itself. Unless otherwise it is approved for one application, you can do the privilege through the role management. Only for this application this port is allowed. That's on the security. So here we are. It's really the last slide. High availability. Your node will go down, your master server will go down, your HCD will go down, and your application will go down. So what do? Two things to take care. Nodes, by default Kubernetes takes care of it. One node goes down, it will take the load to another machine and it will ensure that it is running. But common mistakes, cutting the cost, we used to have two machines, each running with 90% of workload, and one goes down. Already one is running with 90%, push everything into the other machine with the 90% load. So obviously it will try to run, never comes up because already the machine is overloaded. So set up with a proper cluster. When the loads comes, see that 3 machines, kind of 65% is okay. 4 machines, maybe 70 to 75 is okay. You just need to see how much you expect to fail and then do the recalculations, how much on an average it is running. So you need to do some math on it and then set up the cluster size. Master HCD takes care of the storage layer, but still master has one more challenge. It's not active, it's active passive. So even you have 3 masters, something goes down, it has to switch over. But meanwhile, your application will never have any problem because the nodes never stop your application, running application. So you are safe from it. But if you are having an HCD cluster and you want to keep the cost less, the same HCD cluster, 3 nodes can have 3 masters. So kind of this is for the least cost cutting you can do. But if you want a better setup, you can take it. But the master will actually use only one. The rest of the 2 will be silent enough. It will never come to the real picture unless something happens. That's it. Okay, any questions? So did I take too much? I don't know. Thanks guys, thanks for your patience, and I think few of you have been listening to me even they don't understand these jargons. Thanks a lot.